And here we go. Here is the inaugural Algebra 2 video notes. I know you're all excited. So here we are starting on page 10. And so what we're basically doing today is we're starting to talk about this thing called the unit circle. I showed it to you a little bit last time just to scare you. But today it's going to hopefully be a lot less scary. So most of the work we're going to do is going to be on page 10 here. But since we are talking about the unit circle, I will just transfer over here. All the unit circle is a circle with a radius equal to 1. Okay? So if the radius is equal to 1, here's a radius. So then this would be the point 1, 0. This is also 1 upwards, so then this is the point 0, 1. So then by similar logic, this would be -1, 0, and then this would be 0, -1. Okay, so you already have 4 points on the unit circle, albeit the easiest 4 points to get, but you still have 4 points on the unit circle. So these are pretty easy to see just because the radius is 1, but what about points on the unit circle like right there, and so forth? What are those going to be? Well, I'm glad you asked. We are going to discover those on page 10. Okay, but before we can really discover those, we have to have a little bit of a throwback Thursday. And you're going to have to try to remember, because we are going to use these things that I have put up here. These things are called special right triangles. You learned these in geometry. That was a long time ago, I realize. But hopefully just in this quick conversation about it, it can trigger something from geometry. There were 2 different special right triangles, a 30, 60, 90 right triangle and a 45, 45, 90 right triangle. The nice thing about these triangles is that normally you need 2 sides in a right triangle to solve for the third, but in the special ones, you only need 1 side because of this relationship. So in a 30, 60, 90, the smallest side we typically say is x. The side straight across from the 90 is twice that distance. And then the side straight across from the 60 is whatever this is with a times √3 attached. Similarly, in a 45, 45, 90 triangle, we label the legs as x, and then the hypotenuse is whatever that number is with a √2 attached. And the reason that we're going to use that is because all of our coordinates on this unit circle are going to stem from these things right here. So let's take a look what I mean by that. We've already established that this is the point 1, 0. This is the point 0, 1. So what I want to do right now is figure out what's this point, x, y. And to figure that out, we're going to use special right triangles. And the reason we're going to use special right triangles is because I'm going to draw this straight down here. This is going to form a 90-degree angle. This is a 30-degree angle right here. So we want to know at 30 degrees, what are these coordinates? And then so if this is 30, this is 90, therefore this must be 60. So to get these coordinates, x, y, realize your x is the horizontal, so this is x. So whatever distance this is, that's how far you go over, that's your x. And then whatever distance this is, that is your y. Okay, because x, y would bring you to this point. This hypotenuse right here is a radius, and we know that the radius of a unit circle is 1. So I'm just going to transfer this over here so we can see it a little bit better. X, y, and then the radius is 1. So the fact that this is a 30, 60, 90 right triangle is really helpful because now we can come up to here. And in this case, what do we know? We know the side straight across from the 90. So we know this side, the 2x. So we know that this side is twice as big as this side. So this side is twice as big as that side. So if this is twice as big as this, then this has to be 1/2. And if This is 1/2. This side is whatever x is with a root 3 attached. So this would be 1/2 with a root 3 attached. If you want to think about this as root 3 over 1, you multiply fractions straight across, and typically we're going to think of this as root 3 over 2. So the coordinates here, x comma y, your x was root 3 over 2, and your y was 1/2. Okay. So now we have those coordinates, x comma y, root 3 over 2, comma 1/2. And so we're going to continue this similar type of idea. Now I'm going to try to find what this point is right here. This is a 45-degree angle now. And so what you're looking for is this xy coordinate in a 45-degree, 90-degree special right triangle, where once again we know that the hypotenuse is 1. So I'll just transfer that over here to give us some more space. All right. And now if you come back up to this special right triangle, and this is going to be a little bit tricky because here we know the hypotenuse. We don't know the legs. But how do I go from here to here? What's the only difference between hypotenuse and legs? This has a root 2 attached. This doesn't. So if I divided the hypotenuse by root 2, that would be gone, and it would just be x. So what I need to do is I need to divide the hypotenuse, which is 1, by root 2. And this will give me my x and my y, my horizontal and my vertical. It would be really nice if we could leave it like that, but the laws of mathematics say you can't have a rat in the basement. You can't have a radical in the denominator. So remember how we take care of that? You have to multiply top and bottom by whatever this is. So in this case, we multiply top and bottom by the square root of 2 over the square root of 2. And when you multiply straight across, 1 times root 2 is root 2. Root 2 times root 2 is a positive 2. The square roots kind of cancel themselves out here. Okay, so we saw that this and this say exactly the same thing. So this coordinate right here is actually root 2 over 2 times root 2 over 2. The x and the y are the same. So we got this point, that was pretty easy, that was 1, 0. We got this point right here, root 3 over 2, comma a half. We've just discovered this point right here. Lastly, we'll figure out what this one is, and then we'll see how we're going to use this. Okay, so come down, last one here. Now we're going to figure out what this xy point is. So I'll draw in my special right triangle. Because now in this case, this is a 60-degree angle, so therefore this is a 30-degree angle. Here's my x, here's my y to figure out what this coordinate is. So here's my x, here's my y. Hypotenuse is my radius, which is 1. So this is another 30, 60, 90 triangle, except now the 30 and the 60 just ended up switching positions. So what's going to actually end up happening is that these two numbers are going to be the same. They're just going to end up switching positions, right? Because what I have here is I have, once again, my hypotenuse, and the relationship between hypotenuse and smallest side is that hypotenuse is twice as big. So if this is twice as big as x, then once again, x has to be 1/2. And then just as it was up here, if this side is 1/2, the other side is going to be 1/2 times root 3, which we saw was root 3 over 2. So this coordinate is 1/2 comma root 3 over 2. Woof. So a lot of geometry, trig blending there. all just to basically show you where these values are coming from. I think there's inherent value to doing this because otherwise, when you see these values on the unit circle, you're going to just be, otherwise you just be like, where in the world do they come from? Well, where they come from is from special right triangles. Okay, and just for today, we're just going to focus on the first quadrant, which is what we've done right here. Right. So as we fill out this unit circle, we're just going to focus on the first quadrant, which is this one. All right. So what we just saw was at 30 degrees. That was the first one that we did right here. At 30 degrees, the coordinate is root 3 over 2, comma a half. Probably be running out of room here. I apologize. That was at 30 degrees. At 45 degrees, that was the middle one that we did here. We saw that at 45 degrees, our coordinates were root 2 over 2, comma root 2 over 2. So root 2 over 2, comma root 2 over 2. Now that's at 45 degrees. Okay, so this first one was 30. The second one was 45. And then the last one we saw was right here, was a 60-degree angle. And then that 60-degree angle. Sorry, this is getting messy. I should have made this a lot bigger. I apologize. Hopefully you're staying with me. This 60-degree angle, this whole thing right there, ends right there. And we saw that that coordinate was 1/2, comma, root 3 over 2. And next week I'm going to give you another trick to remembering these. But as we think about the unit circle, these are going to be really, really key values that you know. Because if you can know the quadrant 1, then basically the rest of the unit circle fills itself out because it's all just reflected. Okay. So if you go back here and you take a look at this 30, 60, 90 right triangle, if I just look at this 30-degree angle, from this 30-degree angle, I'm going to label O, A, and H for my SOHCAHTOA action. And if you think about cosine, remember, is A over H. So the cosine of 30 is this over this, root 3 over 2 over 1. Well, anything over 1 is just itself. So the cosine of 30 is root 3 over 2. So if the cosine is root 3 over 2, then the cosine is just x. And similarly, what would my sine be? Well, sine is O over H, 1/2 over 1. But 1/2 over 1 is just a half. So the sine of 30 is just 1/2, which is my y value. Which is why when you come to the unit circle, cosine will always be your x value, and sine will always be your y value. And we'll do some examples of that in just a second, but that is very important that you realize that cosine is x and sine is y. So all these x values, 0, 1/2, root 2 over 2, root 3 over 2, 1, all those x values, those are cosines, and then the sines are the y values. Last thing here is tangent. Well, we've already used x and we've already used y, so what could possibly be left over? Well, tangent is going to end up being y divided by x, which is sine over cosine, right? Because we are going to associate y with sine and x with cosine. And just to a real quick, like, hey, yo, Kite, why is that actually true? Well, remember, sine is O over H, and cosine is A over H. So if you don't believe me, here's the proof. The proof is in not the pudding, but the math. We don't divide by fractions, we multiply by the reciprocal. So rather than O over H divided by this, multiply by the reciprocal, which is h over a. The h's cancel out. You have O over A, and SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. O over A is tangent. And notice we started with sine over cosine and ended with tangent, so they are the same. Okay, so the big thing for you to remember from this is cosine x, sine y, and tangent is y over x. If this part right here didn't make any sense, that's fine. Just remember that tangent is sine over cosine or y over x. Okay, so let's just use that here. Evaluate without a calculator. So the cosine of pi. So remember, cosine, you're thinking x. So all this says is, what is the x value at pi? Well, pi is the same thing as 180 degrees, so pi is actually right here. The cosine is the x value right here. My x value right there is -1. And you're done. That's it. And we'll see in our calculators in just a second, if it's in radian mode and you do cosine of pi, you'll get -1. Similar, sine of pi, now you're here, still at pi, but now you're looking for the sine, which is the y value. So the y value there is 0. The tangent of pi, remember tangent is sine divided by cosine, y over x. So the y value is 0. The x value is -1, and 0 divided by -1 is 0. So the tangent of pi is 0. Let's keep going. Cosine at pi over 2. Pi over 2, if you look back earlier in your notes, cosine of pi over 2 is the same thing as 90 degrees. So 90 degrees is going to put you right here. This is a 90-degree angle. And the cosine right here, you're looking for your x value. Your x value at 90 degrees is 0. The sine of 0, you're going back to the same spot. Now just looking at the y value. The y value here is 1. Okay. Cosine of 2 pi. 2 pi is all the way around the circle. So you start at 0. Work your way all the way around. You're back to where you started from. So this is where you're looking at right here. And then the cosine here is 1. Last couple, tangent of 3 pi over 2. 3 pi over 2 is the same thing as 270 degrees, which is down here. Tangent is y divided by x, so it's -1 divided by 0. But you can't divide by 0. So you would say that the tangent here is undefined. You can't divide by 0. 0 can be in the numerator. It cannot be in the denominator. Okay. And last one, tangent of pi over 4. Pi over 4 is 45 degrees. So you come up here. We're looking at these coordinates. And we're also looking at tangent. Remember, tangent is y divided by x. So this is root 2 over 2 divided by root 2 over 2. Well, anything over itself is equal to 1. So we will continue working with this. I know this may be a little bit tricky. Big takeaways here, though, are, okay, where do these things come from? These things come from special right triangles. And then perhaps the biggest takeaway is right here, 2, 3, and 4. Cosine x, sine y, tangent y divided by x. Okay. Some of these we'll be able to just use our unit circle and do without a calculator. All right. You can also just do this in the calculator. Just have to be very careful what mode you're in. So like for letter C, letter E, letter G, letter H, you need to make sure you're in radian mode. And then it actually doesn't matter with 0 because 0 degrees and 0 radians is the same. But then here, you need to make sure that you are in degree mode. So you might be switching back and forth between the modes. So right now, I'm going to be in radian mode. So I'll do all the radian ones first. So this is just mode. And then the third one down, I just changed that back to radians. And so the cosine of 0. That's the x value at 0. Well, the x value at 0 is 1. That's true. So I'm going to put a 1 here. The tangent at 0, well, remember that's y divided by x. Y divided by x, 0 divided by 1. So I'm really hoping here that tangent of 0 is 0. Come on, baby. Woohoo! It is. Tangent of 2 pi over 3. We'll be able to do that on our unit circle, but just so that you can see here, tangent of 2 pi divided by 3. And since I'm in radian mode, what it's going to do is it's going to give it to me in radians. So this is the y over x. This is y divided by x at 2 pi over 3, which is negative 1.732. Okay, and you can do the rest of these. Notice letter G, sine of 20, that's not degrees, so that's 20 radians. Remember, it's about 6 radians all the way around, so that would be, over 3 times all the way around. But once again, you can just put sine 20 on the calculator, and the y value there is 0.913. And since this is in the unit circle, you know that these numbers can't be bigger than 1 because the radius is 1. So the biggest it could be is 1. Cosine at pi over 4, you can type that in as well. Okay, but the cosine at pi over 4, that's 45 degrees. We've already established that that is root 2 over 2. So it is the end up being the same thing. So you could then just switch it back to degrees and do the other ones. Oh, I forgot that one, but that's okay. You can just switch it back to degrees and do the other one on the calculator. But my biggest concern here is making sure that you can feel comfortable doing these without a calculator. And we'll build the unit circle so that we can hopefully be able to do that successfully. Okay. So there's a lot coming at you there. We're focusing on the first quadrant here. Here are your big takeaways. And so hopefully you can apply that, and we'll talk more about it next week. Have a wonderful, wonderful day.